Welcome. In this lesson, we're going to be solving systems of two linear equations. And so one way you can do that is by graphing. And since we have access to a great graphing tool called Desmos, I wanted to show you how to do that, and then we'll use this to just generate the required discussion for this week. So when you have a system of two linear equations, there are three types of possible solutions or possible answers. Sometimes the lines do not cross, they're parallel. And when that happens, there is no solution to the system. We would say does not exist or no solution. Sometimes the lines coincide. There's one line on top of each other, on top of the other. And so there's an infinite number of solutions in that case, which we can represent algebraically. I'll show you that in a different video. But most of the time, the lines cross in one point. And one way to find that place where they cross is by graphing the two lines and just looking for where they cross. And that's what we're going to do in this discussion. So for my example here, I'm going to graph two lines. The first one I'm going to graph is negative 2x plus 8y equals 14. And in the assignment, you're going to be asked to make that line red. So let me show you how to make the line red. After you've graphed a line, if you want to change any of the characteristics, you go to this gear button that says Edit List, and then you'll be able to select this purple circle. It's depending on what color it is, but in my case it's purple. And this allows us to change the characteristics. So I want this line to be red. If you want the line to be a little thicker, you can adjust the thickness number. I'm going to make it a 5 just so that it shows up a little nicer on the screen there. Okay, so we've got the first line graphed. My second line is 3x plus 3 equals negative 6y. And mine came out black. Again, I want that line to be blue, so I'm going to change the value to blue, the color value, and I'm going to change the thickness to 5. Now we can clearly see the red line and the blue line. Now here's where it's cool. If you're doing Desmos on your computer, you can use your mouse, or if you're doing it with your phone or tablet, you can use your finger. And all you need to do is simply tap where they cross, and the intersection will show up there. I obviously tapped it wrong. What's going on here? There. I tapped one of the lines first to get the gray button to show up, and then you can select the point that appears. In this case, it's negative 3, 1. Just to warn you, though, when you tap off that spot, it disappears again. The way you can get it back is simply tap one of the lines, it doesn't matter which one, and then you can select the point. We want that label to stay on there permanently, so what we can do is add a third element to our graph. We can actually type in parentheses negative 3 comma 1 as an ordered pair, and the dot will show up. If you want the values, the numbers to show up with it, you click label, which we do want. So now we've got our label showed up, the ordered pair along with the dot, but we want that to be green, so I'm going to change the color with my gear, and I want that size to be 16. All right, to make it a little bigger. If you want to go bigger than 16, that's fine. Let's see what 20 looks like. 20 is not bad either. So I'm going to make the size of that 20. Now that point is permanently on there. So we used the features of Desmos to find that point by tapping on the intersection. And then we added a label so that it stays permanently on our picture. So the solution to this system is negative 3, 1. Here's one little comment. So when that number those two numbers that we found, that ordered pair, those are values that make both equations true. For example, if I do negative 2 times negative 3 plus 8 times 1, I get 14, which is what our equation says up here. It's supposed to equal 14. If I compute 3 times negative 3 plus 3, that value is negative 6. And if I do negative 6 times 1, that's the right side of that. That value is, oops, that's supposed to be negative 6 times 1. Negative 6 times 1, I also get negative 6. So those two values are equal. So we found an ordered pair that makes both equations true. You don't have to add that to your picture. I'm just demonstrating that we did find the correct solution. Okay, so hopefully this sets you up for the discussion. Your job, which I've already written out in the instructions, is to graph a different system, locate its solution, add that solution to the picture, make the first line red, the second line blue, and the ordered pair green with its label. Take a screenshot of this and then post it to the discussion. And then I will look at your work and your classmates will. If everything looks great, we're just going to give you a great compliment. If there's something we think you need to fix, we'll ask you to do that, just so that you can get the hang of how to work with the software. If you have any questions, of course, please let me know. In the meantime, take care.